we discuss about the some topics related to what are the different parts of the network functions and that driving point impedance and transfer impedance and driving point admittance and transfer admittance, like that you have to see. And then we discuss about the what are the synthesis of the networks. Under that synthesis we discuss about the what is different techniques, that is fast 1, fast 2, cover 1 and cover 2. And then we see about the what is a Fourier series, and then what is Fourier series and what are the even and odd functions, and what are the complex functions of the Fourier series, like that, and some related problems about that Fourier series. In this class we discuss about the what is Fourier transforms. Fourier transform is, generally we see that the Fourier are used for analyzing periodic signals. While using to find out the periodic signals, we have used this Fourier series. And what is the Fourier transformers? It is used not only periodic and non-periodic signals you have to use, that is called as Fourier transforms. So this is the basic relationship. So we know that Fourier series are used in analyzing periodic signals, but many more signals or aperiodic needs a more general tool, that is called as Fourier transform. So Fourier series will be to find out the periodic signals, but when you have to find out that not only the signals are only periodic is not there. So when you have to, there is a, so most of the signals must be a non-periodic signals must be there. So for finding the periodic and non-periodic signals, for you have to use the tool will be called as Fourier transforms. Fourier's own derivation of the CT Fourier transforms. So x of t and aperiodic signals and aperiodic signal view it a limit of periodic signals t to infinity. For the periodic signals, the limit will be t to infinity. So the harmonic compounds are spaced omega naught is equal to 2 pi by t apart, where as t is to infinity and omega naught is to 0, then omega is equal to k into omega naught. This is because of continuous signals, Fourier signals in terms of Fourier intervals. So in view of this periodic signals, so the limit of the periodic thickness at the t equal to infinity. So at the harmonic component at spaced omega naught is equal to 2 by t. So at terms t is to infinity and omega naught is t. So then omega equal to k into omega naught becomes a periodic, becomes it is a continuous. So when you observe this, so on the derivative of Fourier transforms, so for simplicity assume x of t as a finite duration. So x of t as a finite duration. To introduce the periodic x of t is equal to x of t at what interval you have taken minus t by 2 to is less than t, it is less than t by 2, and the periodic it is magnitude of t is greater than the t by 2. So when you have observed this, when you, the what is the periodic in between this x of t is minus t by 2 to t by t. So as t is infinity and x of t is equal to x of t for all with respect to of the t. So how you have to derive it? So generally we know that the equation of the Fourier transform x of t is equal to summation of minus infinity to infinity a k e power j k omega naught t, a k e power j k omega naught t. That means omega naught is nothing but the amplitude with respect to time, that is 2 pi by t. So when you have to find ak is equal to 1 by, when you have to find ak from this equation, ak is equal to 1 by t integral of minus t by 2. For the intervals you have to take is t by 2 to t minus t by 2 to t by 2. So minus t by 2 to t by 2 x of t e power minus j k omega naught t dt. So that is equal to 1 by t integral of minus t by 2 x of t e power minus j k omega naught t, because here the omega is nothing but the 2 pi by t. So x of t is equal to x of t in this interval. So 1 by t integral of minus infinity to infinity x of t e power minus j k omega naught t dt. So if you define x of j omega in terms of the x of j omega is equal to, in terms of t, we have taken x of t is 1 by t integral of minus infinity to infinity x of t e power minus j k omega naught t. So in terms of x of j omega is equal to minus infinity to infinity x of t e power minus j omega t dt. So hence the equation 1 ak is equal to x of j k omega naught by t. So thus for minus t by 2, that is minus t by 2 is less than t by 2. So x of t is equal to summation of k equal to minus infinity to infinity 1 by t x of j k omega naught into e power j. So we have to substitute how much value you get, that is x ak value is how much, x of j k omega naught by t. Already we have to, so we have to substitute in this equation from ak. So then what is the equation we get? X of t is equal to summation of minus k into minus infinity to infinity 1 by t x of j k omega naught is nothing but ak e power j k omega naught t, that is equal to 1 by 2 pi, where omega is equal to 2 pi by t, summation of k minus infinity to infinity omega naught x of j k omega naught e power j k omega naught t. So as t is infinity, omega naught respect to 0, and summation of omega naught is equal to integral of d omega, and k omega naught is equal to omega. So we get a continued transfer function and finite transform pair. You observe that x of t, when in terms of the t, that is x of t is equal to 1 by 2 pi integral of minus infinity to infinity x of j omega e power j omega t d omega. This is synthesis equation. So when this analysis equation, when in terms of x of j omega is equal to minus infinity to infinity x of t e power j omega t dt. So x of t is equal to 1 by 2 pi integral of minus infinity to infinity x of j omega e power j omega t d omega. In terms of synthesis equation, in terms of j omega, x of j omega is equal to minus into infinity x of t e power j omega t dt. So from Fourier series, we observe that in terms of x of t is equal to 1 by 2 pi integral. This is the formula for the Fourier transforms. X of t is equal to 1 by 2 pi integral of minus infinity to infinity x of j omega e j omega t d omega in terms of omega. When you have to Fourier transforms, inverse Fourier transforms, x of j omega is equal to minus infinity to infinity x of t e power j omega t dt. So when you have to remember these two things, so x of t is equal to 1 by 2 pi minus infinity to infinity x of j omega e power j omega t d omega, and x of j omega is equal to minus infinity to infinity x of t e power minus j omega t dt. So there are, when you observe, this is the main formulas of the Fourier transforms, and there is some properties of this Fourier transforms. So we have to go with one by one. That is, first one, it is called as linearity, the properties of linearity. So generally we all know the expressions of the Fourier transforms and its inverse. So when it will be synthesis form, x of t is equal to 1 by 2 pi integral of minus infinity to infinity x of j omega e power j omega t d omega, and x of j omega is equal to 1 by t integral of minus infinity to infinity x of t e power minus j omega t dt. For these two equations, we all go through about the what are the different properties you get. First one, it will be linearity. So the property of linearity, generally when it will be the linearity, two variables must be there. That is f of Fourier of a into x of t plus b into y of t is equal to, we have to prove a into x of j omega plus b into y of j omega. So we have to prove Fourier of a into x of t plus b into y of t is equal to a into x of j omega plus b into y of j omega. So how you have to prove? So generally a into x of t plus b into y of t is a into x of j omega plus b into y of j omega, or a into x of j omega plus b into y of j omega is a of x of t plus b of y. So how you have to prove? So we have to take this equation f into Fourier of a into x of t plus b into y of t. So it is the x of t is, what is the equation we know? 1 by 2 pi to integral of minus infinity to infinity x of j omega e power j omega t d omega in terms of synthesis. So we want the form in terms of the j omega. So what is the x of j omega is 1 by t integral of minus infinity to infinity x of t e power j omega dt. So we have take this equation a into x of j omega, that is 1 by t integral of minus infinity to infinity a into x of t plus b into y of t e power minus j omega t dt. So write down these two equations in separate form. 1 by t integral of minus infinity to infinity a into x of t e power minus j omega t dt plus 1 by t into integral of minus infinity to infinity b into y of t e power minus j omega t dt. So when you have to a constant, that is a equal to 1 by t integral of minus infinity to infinity x of t e power j omega t dt plus b into 1 by t integral of minus infinity to infinity y of t e power j1. We already know that what is 1 by t integral of minus infinity to infinity x of t e power minus j omega t. It is x of j omega. Same thing, 1 by t into integral of minus infinity to infinity y of t power j omega t dt is equal to also y of j omega. So we get the formula a into x of j omega plus b into y of j omega. So Fourier of a into x of t plus b into y of t is equal to a into x of j omega plus b into y of j omega. This is the linearity property. Next one, time shifting property. What is time shifting property? So under the time shifting property, you have to prove x of t minus t naught is equal to x of j omega e power minus j omega t naught. So how you have to prove? So Fourier of x of t minus t naught is equal to 1 by t. This is the formula. Minus infinity to infinity x of, so in terms of x of t, we have to write x of t minus t naught e power minus j omega t dt. Make the changes of variables lambda equal to, we have to assume lambda equal to t minus t naught, which implies t equal to lambda plus t naught. So we have to substitute that values. So f of x of t minus t 1 by t integral of minus infinity to infinity. So x of t is nothing but the t minus t naught is nothing but the lambda. So x of lambda e power minus j omega. What is t value here? I am taking lambda plus t naught. So lambda plus t naught d lambda. So 1 by t integral of minus infinity to infinity x of lambda e power minus j omega lambda into d lambda e power minus j omega t naught. So we get the value. So total this equation comes to x of j omega. So x of j omega e power minus j omega t naught. Note that this means that time delay is equivalent to linear phase shift in the frequency domain. So we, as a filter, we have to refer that x of j, magnitude of x of j omega is equal to 1, lambda x of j omega is not equal to 0. So phase shift is important concept for development of the surrounding sound. This is time shift. Next one is time scaling. So what is time scaling? Time scaling is equal to x of at is equal to 1 by magnitude of a x of j omega by a. So how we have to prove this time scaling property? So proof f of x of at is equal to 1 by t integral of, so in terms of x of t you put x of at, so minus infinity to infinity x of at e power j omega minus j omega t dt. So assume a is greater than 0. So for making a changes of variables, assume lambda equal to at, which implies t equal to lambda by a, and dt is equal to 1 by a into d lambda. So substitute this value in this equation. F of a into x of at is equal to 1 by t integral of minus infinity to infinity x of at, in the place of at we substitute lambda, in the place of t we substitute lambda by a, and in the place of dt we substitute 1 by a d lambda. So 1 by a into 1 by t integral of minus infinity to infinity x of lambda e power minus j omega by a into lambda into d lambda. So that is equal to 1 by a x into j omega by a. So when a is greater than less than 0, the negative values is offset by the change in limits of integration. When a is less than 1, on the frequency, on the time domain waveform, on the frequency response, it is a is greater than 1. So this is about the less than, the negative value will be offset by the changes in the limits of the integration. Next one is time reversal property. So time reversal property, under this x of minus t is x of j omega. So proof f in terms of x of t we place x of minus t. So x of minus t is equal to 1 by magnitude of a x of j omega by a, that is equal to x of minus j omega. So we can also note that the real value signals x of minus j omega is equal to x of minus j omega at the magnitude of x of minus j omega. So x of j omega, the magnitude of x of minus j omega is equal to x conjugate of the x conjugate of the j omega. So time reversible is equivalent to conjugate in the frequency domain. Conjugate in the frequency domain. Next one, multiplication by power of t. Multiplication by a power of t. So multiplication by a power of t, where t power n x of t is j power n d power n by d omega power n x of j omega. So what is the proof? So x of j omega is, we already know that it is value is 1 by t integral of minus infinity to infinity x of t e power minus j omega t dt. Differentiate with respect to omega. So when you have to differentiate, dx j omega by d omega is equal to 1 by t minus infinity to infinity minus jt x of t e power minus j omega t dt. Multiply by j. So we have to multiply both sides with j. J into dx j omega by d omega is equal to j into 1 by t integral of minus infinity to infinity minus jt into x of t e power j omega minus j omega t dt. So that is equal to 1 by t integral of minus infinity to infinity of t x of t e power minus j omega t dt. That is equal to Fourier of t into x of t. T into x of t. So same thing you have to repeat for the high power also. Next, multiplication by a complex exponential modulation. So what is formula? What we have to derive that? X of t e power j omega t is x of j into omega minus omega naught for any real numbers omega naught. So we have to take x of t is equal to x of t e power j omega naught t. So that is equal to minus infinity to infinity x of t e power j omega naught t e power minus j omega t into dt. So x of t e power, when you have to take in common, that is minus j omega minus omega naught t, that is equal to, where x of t e power minus j omega j t dt is nothing but the x into j into omega minus omega naught. Another property is x of t cos omega naught t is equal to x of t e power j omega naught t plus e power minus j omega naught t by 2, that is equal to half into x of j omega plus omega naught plus x into j omega minus omega naught. Next one, differentiation. Differentiation or integration. So differentiation domain will be d power n by dt power n x of t is j omega power n x into j omega n. Integration of time domain is minus infinity to infinity x of lambda d lambda is 1 by j omega x of j omega plus pi x of 0 into d omega. Though this is the time domain differentiation in the frequency domain. So this will give in the form of additive noise, and what are the different properties we have to use this in the unit pulse and unit step. Next one is convolution in the time domain. This is the another property, that is convolution property. So convolution in the time domain, x of t into h of t is x of j omega h of j omega. So proof, x of t into h of t is equal to minus infinity to infinity x of lambda h into t minus lambda into d lambda e power minus j omega t dt. So minus infinity to infinity x of lambda is minus infinity to infinity h of t minus lambda e power j omega t dt into d lambda. So change these variables where lambda gamma is equal to t minus lambda, where d gamma is equal to dt. So I have to substitute that minus infinity to infinity x of lambda into minus infinity to infinity h into h of gamma e power minus j omega gamma plus lambda into d gamma into d lambda. So for that we get minus infinity to infinity x of lambda e power minus j omega lambda d lambda minus infinity to h of gamma e power minus j omega gamma into d omega. So we get the value x of j omega into h of j omega. This is the convolution time domain. So other important multiplication of the time domain is x of t into y of t is 1 by 2 pi x of j omega into y of j omega. That is equal to 1 by 2 pi minus infinity to infinity x of lambda into y omega minus lambda into d lambda. Parseval's theorem is minus infinity to infinity x squared of x square of t dt is equal to 1 by 2 pi integral of minus infinity to infinity x of j omega square d omega, and the duality is x of t is 2 pi into x of minus omega. So what are the different properties? Must be, when it will be linear, what is the property? A x of t plus b y of t is a into x of omega plus b into y of same time scaling is x of a t is 1 by a x of omega by a, where time reversal is x of minus t x of minus omega, and multiplication of power t is equal to t n x of t into j n dn by d omega n. So there is the linearity, time scaling, time reversal, multiplication by complex, multiplication by power in terms of the sign, in terms of the cos, differentiation time domain, integration, convolution of the time domain, multiplication of the time domain, Parseval's theorem, and duality. These are the properties depends upon this Fourier transformers. We'll see about some problems about this Fourier series. So determine the Euler coefficients of this Fourier series of the function f of x equal to x for minus pi less than or equal to x less than or equal to pi. So we have to find out the Fourier series. We have to find out the coefficients a0, an and bn. What is how you find out an? A0 is equal to 1 by 2 pi integral of minus pi to pi. What is f of x dx? F of x is x into dx. So we get the value is 0. Same thing in terms of an, you have to find 1 by pi minus pi of pi. F of x is x cos nx dx. So that is equal to, when you have to 1 by n square integration n square by pi cos nx plus x by n pi sin nx by pi into minus pi, that is equal to 0. Next, bn is equal to 1 by pi integral of minus pi to pi x sin nx by dx. Same thing, 1 by n square pi sin nx minus x by n pi cos nx. So we get 2 by pi minus 2 by n cos n pi is equal to 2 by n cos n pi, that is minus 1 into n plus 1. So we get the values a0, an and bn values. So another problem, that is expand f of x equal to x square. So now you have to put in the place of f of x, you have x square with the terminal, with the derivations of this integrals of 0 to less than x less than 2 pi Fourier series. So prove that 1 by 1 square plus 1 by 2 square 1 by 3 square is equal to pi square by 6. So we get the period is 2L is equal to 2 pi, then L equal to pi, and choosing C equal to 0. So an is equal to 1 by L integral of C plus 2 pi f of x cos n pi x by L. So 1 by pi integral of 0 to pi f of x cos n x dx. So 1 by pi x square sin nx by n minus 2x into minus cos nx by n square plus 2 into minus sin nx by n cube 0 to 2 pi, that is equal to 4 by n square. Like that you have to find out a0. A0 is 1 by pi integral 0 to 2 pi x square dx, that is equal to 8 pi square by 3. So we have to substitute this value in terms of that is f of x is equal to, they have already, we have done f of x is equal to x square. So put x square value there. And here bn is equal to 1 by pi integral of 0 to pi f of x is x square sin nx dx. So x square into sin nx dx. So 1 by pi x square into minus cos nx by n minus, so a into b form minus 2x into minus x square is nothing but sin 2x. So minus sin nx by n square plus 2 into cos nx by n cube into 0 to 2 pi. So we get the values minus 4 pi n. For that you get the value f of x is equal to x square, that is equal to a0 is 4 pi square by cube, and summation of n equal to 1 to n. An means 4 by n square cos nx and bn is minus 4 pi n sin nx. So at x equal to 0, the above Fourier reduces to 4 pi square by 3 plus summation x, in the x place we put the 0. So summation of n equal to 1 to infinity 4 pi n square. So x equal to 0, the point will be discontinuity. So by Dirichlet conditions, the series Dirichlet condition, the series convergence x of g equal to 0 plus 4 pi square by 2 pi is equal to 2 pi square. So 2 pi square is equal to 4 pi square by 3 plus summation of n equal to 1 to infinity 4 by n square. So summation of n equal to 1 to infinity 1 by n square is equal to pi square by 6. That we have to prove. Next problem, find the Fourier series expansion for the following period function of period 4. So here they have taken two conditions, f of x equal to 2 plus x minus 2 less than or equal to x less than or equal to 0 and 2 minus x 0 less than x less than 2. So f of x plus 4 is equal to f of x. So put the f of x value is 1 by 2 integral of minus 2 to 0. We have to put 2 plus x dx. And 0 to 2 we put minus 2 minus x dx. So 1 by 2 integration is 2x plus x square by 2, that plus 2x minus x square by 2, that is equal to 2. Same thing, an is equal to 1 by l, 1 by 2 minus 2 to 0, 2 plus x cos n pi x by 2, n pi x by 2 dx plus 0 to 2, 2 pi x cos n pi x by 2 dx. So when you have to solve this equation, we get the formula 4 by n square pi square into 1 minus minus 1 whole power n. So 0 for n is even. When n is will be odd, we get 8 by n square pi square. Then how you find out the bn is equal to same thing in terms of sign. 1 by 2 integral of minus 2 to 0, 2 plus x sine n pi x by l dx plus 0 to 2, 2 minus x sine n pi x by l dx. So 1 by 2 into 2 plus x into sin n pi x by l minus cos n pi x by 2 by n pi by 2 minus 1 into minus sin n pi x by 2 minus x n square pi square by 4 at minus 2 to at the intervals minus 2 to 0. And next thing 2 minus x into minus cos n pi x by 2 by n pi by 2 minus of minus 1 minus n pi by x by 2 by sine n square pi square by 4 at interval 0 to 0. So first you have to integrate the first one thing, and then you have to integrate the other thing. Then you get the total f of x is equal to 1 plus 8 by pi square summation of n equal to 1 to infinity. So 1 by n square into cos 2n minus 1 into pi x by 2. So for this problem also you have to find out when you have to get the Fourier series, when they have to use the any term, you have to find out the a0 value, an value and bn value in terms of the a0 f of x dx. In terms of the an, you have to f of x in terms of cos. When you have to find out the bn, f of x in terms of sine. So in this class we discuss about what is the Fourier transforms and what are the different properties of the Fourier transforms and some of the problems related to the Fourier series. Thank you.